Alright, this is the video going over our Target 1.1 notes. Again, you can watch this if you had to miss class for any reason, or you got distracted, or you really just want to go over it again after we went over it in class already. Okay, so you really can watch it multiple times if you want, or have it open while you're doing your homework. Okay? So we're looking at Target 1.1, and it says I can solve problems involving ratios by using the cross product property. Okay. So a ratio, so that's our first definition. Okay, ratio. See if it. Okay. A ratio is just a comparison of two quantities. So we use it to compare numbers. Miles per hour is a ratio. I'm comparing the number of miles I'm driving to the time, okay? And so we'll often write it as a fraction, like miles per hour is not. It's just a number. It's been reduced already. So 60 miles per hour is 60 miles divided by 1 hour, okay? And a proportion is simply any two ratios that are equal. So the time we kind of use proportion is if you think about recipes. If you have a recipe for something and it's going to serve 4 people and you have 8 people coming over, if you double all your ingredients, it's still proportional. If you divide your fraction, they're going to be equal even though the numbers aren't equal. Okay? So it's if I double everything, the proportions are all still equal. All right, let's look at an example, or some examples. At Logan's High School, there are 190 teachers and 2,650 students. What is the student-to-teacher ratio? So I want to go from student to teacher. Okay. So I have 2,650 students, and since I want student to teacher, I'm going to start with that student. So I start with 2,650 students. Two is kind of where our fraction would go. It's so laggy. Oh gosh. Okay. And then teacher, there are 190 teachers. I'm going to pretend to write like it's not lagging. Seems to be writing just fine. Okay. Okay. Then I'm going to open I'm going to split the screen here. I don't have a thing. There it is. Okay. So I'm going to just divide 2,650 divided by 190. It automatically gives me the answer. And since it's 13.9, I can get it as a fraction. So if you hit this button right here, it gives it to you as a fraction. So that's a good trick to know. So that's okay. But if I get it as a decimal, that's fine too. So I'm going to say it's approximate, right, if I'm rounding. So we use these squiggly lines. That lets me squiggle line. Okay, so if the equal line is squiggly, it means it's approximate. And I'm going to round that 13.9 to 14. So it's approximately 14 to 1. That squiggly line means approximately. fractions, we have approximately 14 to 1. I don't know how these blue lines got down here. Okay. Let's look at our example 2. Determine whether each pair of ratios form a proportion. So if they form a proportion, it means they are equal. So if I'm going to look at 6/10, right, I want to see if I can reduce this fraction. And I can divide both 6 and 10 by 2. Six divided by 2 is 3. 10 divided by 2 is 5. So if we look here, this 6/10 is equal to our 3/5. Those two things, right, because that's what we just found it to be. So these are a proportion. I could spell. Okay, looking at part B, again, I'll start with the 12 out of 24. I can divide both of those by both 12 and 24 are divisible by 12. So 12 divided by 12 is 1, 24 divided by 12 is 2. Again, you can always use that Desmos calculator to help you out with getting these fractions as well. I'm going to do the same thing with our 2/6. Both of these are divisible by 2, right? Two divided by 2 is 1. 6 divided by 2 is 3. Okay? So I have 1/2 and 1/3. Those are not the same fraction. So 12/24 we would say is not equal. And again, our not equal symbol is just equal with like a slash through it. So it's not equal to 1/3. So then I would say this is not a proportion. Okay, looking at our next example, example 3. Oops. Example 3 says solve for x. We have x over 3 equals 24 times 18. Well, currently x is being divided by 3, so I'm going to multiply both sides by 3 because I'm doing the opposite. The opposite of division is multiplication. Those 3's cancel out, and I'm left with x equals, and then I would just need to know, there it goes, x equals 24 divided by 18. I would just need to know what 24 over 18 times 3 is. And 4 divided by 18 times 3. Nope. That's my way right now. This is a good thing to be careful of, so it is still on the denominator, so make sure that times 3 is not in your denominator. Times 3. There we go. I'll move that back down. And it gives me that it's equal to 4. So this is a proportion. this proportion is nice and easy to solve by just multiplying by 3. Not all proportions are that easy to solve, okay? So for more complicated ones, we have what we call our cross product property. That is our next definition. And our cross product property says, in a proportion, the product of extremes is equal to the product of the means. Now those are big words, but all it says is this. If I have like A over B equals C over D, my product of A times D is equal to the product of B times C. Okay, so A and D are your extremes, and B or C are your means. You're not really going to have to know those words, so just like kind of remembering this picture is really what you want. Okay. And why do we care, right? We just saw that this was a very easy problem. We did in example 3. Well, this is useful when your variable is like in a denominator, because you can't just like multiply like that. Or if you have more than one variable in your problem, you also have to use the cross product property. All right, so let's look at example 4. We have A, B, and C. Example 4A. Again, I'm going to multiply four times 11. I'm going to multiply x times 6. Well, 4 times 11 is 44. And x times 6, again, we usually just put that coefficient out in front. And I get 44 equals 6x. We're going to divide by 6. Well, 44 divided by 6, using my handy dandy calculator. And we can round, that's fine, so I'll say 7.3. Since I rounded, I have to use that approximate. And on the other side, again, why do we divide by 6? Because those cancel, right? So we just are left with x. So 7.3, so x is approximately 7, make that a bigger dot, 7.3. All right, looking at example B, very similar, but now we have to be very careful. Anytime we see a plus or a minus sign, we have to put parentheses. Okay, so I'm going to put a parentheses around that x plus 3. Because then when I multiply, I get x plus 3 times 5 equals, we have 2 times 4x on the other side. Okay. So since there is this plus or minus sign, we have to distribute. So I have to do 5 times x, which is 5x, and then 5 times positive 3, so I get plus 15. Equals 2 times 4x is 8x. Okay, one thing to note is if you have x's on both sides, maybe, sorry it's so laggy. Look at the screencasting. I don't know why it's like that. if you have x's on both sides, then you want to get rid of one of them. Subtract 1. So I have a 5x and an 8x. It doesn't really matter which one. I tend to do the one that also has something else with it, or if they both have something else with it, it really doesn't matter which one. So I'm going to subtract 5x. Okay. And those cancel. So now I'm left with just the 15, and 8x minus 5x is simply 3x. Okay? And now I can just continue by saying, okay, I'll divide by 3, divide by 3. My 3's cancel. 15 divided by 3 is 5. I can use the equal sign here for with x because I didn't round that. 15 divided by 3 divides nice and evenly. Okay, last problem. We have x plus 3 over 8 equals 4 times x minus 1. So again, now here, this has a plus sign, and this has a minus sign. Again, whether it's plus or minus, anything with either of those has to have put parentheses around it. So x plus 3 times x minus 1 is going to equal 8 times 4. Okay, we have to distribute twice in this problem. So I have to do this x times both of these things. So x times x is x squared. X times negative 1 is minus 1x. And then I have to do the 3 times both of those things. So 3 times x is 3x. 3 times negative 1 is minus 3. And 8 times 4 is then 12. So now I have x squared, and then minus 1x plus 3x is 2x when I combine my like terms, and then minus 3 equals 12. Okay, now this has an x squared. My s's don't come out right. If there's an x squared set equal to 0. Okay, so right now this is x squared plus 2x minus 3 equals 12. That's not 0, right? Oh my gosh. Guys, that's wrong. 8 times 4 is not 12. You might have caught it already. I apologize. 8 times 4 is 32. Okay. Either way, 32 is also not 0. Okay? So I want to make this 0. In order to make this 0, right, I have to get rid of all 32 of it. My 3's are rough, sorry guys. So now I have x squared plus 2x minus 35 equals 0. What do we do then? This is something you kind of learned during pandemic time last year. But we're going to factor it. Okay? So what does that mean? Well, if I have x squared plus, I'm going to make that 2 in red, plus 2x, and then plus 35 equals 0. Oh, minus 35. Okay. Well, remember, we want to multiply to this, maybe remember, we want to multiply to this last number. So we want to multiply to negative 35. And we want to add to that middle number. So I want to find two numbers that multiply to negative 35 and add to 2. Again, this is something you may have learned during the quarantine time last year. So I don't have high hopes for us remembering it, so that's okay. So I'm going to be putting in a lot of examples that have factoring in it, so we start to see it, because it's really going to be important next semester. Okay? So I'm looking for two numbers that multiply to negative 35 and add to 2. I know that 7 and negative 5. Okay, these numbers you just start seeing. Okay, but 7 times negative 35 is, or 7 times negative 5 is negative 35, and 7 plus negative 5 is 2. Okay, so I take those two numbers and I get x plus 7 and x minus 5 equals 0. Okay. And then our last step is we just split these apart. So we have x plus 7 equals 0 and x minus 5 equals 0. And then these are two separate equations. Minus 7 plus 5 Okay, so I get my two answers, x equals negative 7 and x equals 5. All right, that is it. If you have any questions while you're working on your homework, replay this video, or you can always message me for any questions you have. Okay? All right, guys. See you later.